Hello guys, and welcome back. And welcome back to a video about these things, junction boxes. In this case, a high voltage junction box. I am trying to figure out what is going to be the best way for me to set up the junction box for my electric car, which is over here. And I have choices. And you know what it's like when you have too many choices? It's like when you go into a car park and there's an empty car park and you can't decide where to park because there's such a choice. Yeah, well, I'm kind of in that situation. Basically what I've done is, as you probably already know, I bought a couple of electric e-Golf battery packs, and this is the junction box that came out of one of them. Over the last year or so, I've also bought a Gen 1 Nissan Leaf battery junction box and a Gen 2 Nissan Leaf battery junction box. And what I've been doing is messing around. Sorry, I also bought a couple of these Kilovac. What is it there? Kilovac Zonka 3 relay. Bought a couple of those about a year and a half ago. And so what we have for choices are, we can go for, basically take the electronics out of the e-Golf battery pack and use it as it is. But it has 4 relays and I don't really need 4. In the e-Golf it uses 2 for driving the car and 2 for charging the car when it's connected to a DC high-speed charger. And I won't have that situation, not for some time, so I don't need the extra. And if I put this into the into my plastic box as it is, it basically will fill the box by itself and leave very little room for putting connectors on the side of the box and so on. So that, I think, is out. So what I did was I took the second one that I have of these and basically cut off bits like that. So I've got something to hold the fuse and the resistor and the relay. So that's a possibility. Or I could just go down the road of putting in individual contactors and connect them individually. Or I could put in the Gen 2, or I could put in the Gen 1. So what am I going to do? Well, I know I can't use these. That's one thing's for sure. At least I can rule these out, because this one, when I activate it, has a resistance which varies between 10 ohms and a kilo ohm across the connectors. So that goes straight in the bin. This one is okay, it's given 0 ohms, but because it came at the same time as the other one, I'm not going to use it. I could use the Gen 1 contactor box, but it leaves very little room for connections at the end. It is quite big, so I don't think I'll be using that. So my choices really are, do I go with this and set a couple of contactors out like that, just wherever they go, or do I go with this, which is a lot neater than the Gen 1. The only problem with using this is that I've already cut down one of the contactors, this one, and fitted it into this box in this position. I did that when I didn't know any better. So what do? I can't decide. But I think I will probably go down the road of using this. because that can go nice and neatly out of the way over there or somewhere like that, and leaves lots of space for contactors. I think that's probably the way I'll go. Now, as for connecting to the contactor box, I've decided that the main output will come from this, which was originally VW, and it can go on the side there. And the nice thing about this is, I'll bring you over to the car now. The nice thing about this is, take these out of the way. This is the main input for the car, as you can see. And the way it plugged into the original Nissan Leaf box, this bit plugged directly into the PDM, the power distribution module. And I've decided not to use that for a couple of reasons. But this is a connector which is, I can't remember where I got that connector from. I think it maybe came off the battery pack, the battery box. But anyway, it matches the connector coming out of the inverter. So as you can see, the leads are quite long. But all I need to do is get a plastic box of some sort to put that into. And that would give me a lovely connection there. And then this comes up with a right angle connection. And that goes into that. Oops. That goes into there. Which means that I can have that down there, something like that. You piggy. Is it going to work? Single-handed. Yes. Right. So that goes in like that, and that will be on the end of the box. So that can just sit there nicely, and it wouldn't be very hard to tie that up and keep it nice and safe. So that's a nice easy way to get the high voltage from the high voltage junction box into the inverter. Now, I have other connectors and bits and pieces which were on the power distribution module. So if I was to various connectors here, so I should be able to take them apart, take them off, put them onto my box wherever I need them, and they could be used for taking high voltage to the heater, charger, and wherever else they need to go to. So that's, I think, the road I'm going to go down. Which of course means that this box is way bigger than it needs to be. I probably could have done with one half the size, but it is what it is. It's what I've got, and I'm going to stick with it for now. I have even made for it a metal plate. I made this out of aluminium, so I can screw my bits and pieces to the metal plate, and then screw the metal plate with these holes to the box. So I think what I'll do is I will start from the inverter over there and the plug for it, get that put into this, and then work my way back from that, because that's something that I do know I can do. The battery connections will be coming in through, they'll probably be going in through glands like these. So I'll use these glands to bring the battery connections in. Now, one thing which I had not been considering up until now, and is just realised in the last day or two that I'm going to have to concern myself with, is the safety of the battery boxes. Now, there is one of my battery boxes which I'll maybe put up a picture of the batteries inside this box. But that's one of my battery boxes that I've made that sometime last year. And the problem with that battery box is that all the batteries are really tight fit in it. And I've discovered that I will need to put a fuse in it and a high voltage disconnect in that particular box, and I'm not entirely sure how I'm going to go about doing that. I might be able to have the high voltage disconnect accessible through a hole in the floor of the car, which would have been originally for the to get access to the fuel tank, and so I might be able to use that to get access to the high voltage disconnect. That might work, but I still need to put a fuse in there, and I've only got 2 fuses, one here and another one here, and these fuses are very expensive. It's a 400 amp fuse, so I'm going to have to figure out how I get around that. Anyway, enough talking. Let's get the connector put in the end and take it from there. Right, so I have this mounted now, screwed in with M5 screws, and I've realised that it has a little switch on it. This connection, which goes to here, when you plug in a lead, a connector in there to plug in in my case, the inverter, when you plug the inverter in there, as soon as that lead goes in, it shorts out 2 pins in this connector and shorts out this. Now the nice thing about that is, this is the 12 volts connection to drive the contactor, and if that goes through that connection, that means that if this thing is live and somebody pulls the plug out, it will turn off the high voltage. It will turn off the contactor, kill the part of the contactor, turn that off, and these 2 connections here will not go live. So that is something that I want to use. I think that's always allow for the next idiot coming along behind you. It might be you. I could someday accidentally unplug this while the thing is still live and have potentially 400 volts sitting there. I don't know. I might do. I don't know how stupid I'm going to be in the future. I'm pretty stupid now, so if I'm stupid in the future, that won't be any surprise. So anyway, try to mitigate for my own stupidity in the future by using this connection, which means that the main contactor cannot go live unless the plug is in place. So now what I'm trying to do is to try and figure out what bits of copper I have that could go in position, could be bent into position to make our connection to the contactors. Probably what I'll do is I have tons of this stuff. It's the bus bar that came out of the eGolf battery pack. Got loads and loads of this. Probably what I'll do is just bend it over and just keep it simple and use a bit of bus bar. Drill a hole in it, screw it in. Right guys, well excuse the mess, but I've decided to go down this road. As you can see, I've got a portion of the eGolf contactor box, sort of just the bits that are going to hold the fuse for me, the relay for the pre-charge resistor and the pre-charge resistor itself. I kind of figured I could spare the space to have them nice and securely mounted. As you can see, I've got nice bendy ends on the connecting to these contactors onto main connector, connector to the inverter. So now what I need to figure out is which side is pause and which is neg, because the fuse has to go to the pause side and I'm not sure which is which. So before I secure anything or make up any final links, I need to work out where the pause is. And what will probably happen is the neg will be coming in from the first battery box, or the last battery box, the furthest away battery box. It'll be going in, just straight in through a grommet and or compression gland, and straight in through a gland and straight up and straight to the negative here of the contactor. And then when the contactor switched, that switches the negative out, left or right, whatever it is. So that's probably what I'll do. The main positive coming from the first battery will obviously have to come in and join onto the fuse, go through the fuse and then into the contactors. Well, as you can see, guys, I've actually marked one of these as positive by putting some red tape on it. And the reason I was able to do that is because, well, first of all, the last time I tested this, I actually put on the thing. If you can see it, there's a white pause there and a white neg there, marked on the terminals. But just to double check, I went back and looked at my previous videos, and I could see from the videos that this was indeed the pause. So we're going to go with that. And yeah, an ice cream tub is probably not the best insulator for this, but for testing purposes it'll do the job. It's just something to just to protect the wires from touching anything. As you can see, the terminals are well sort of held up in the air. They're not close to anything. Put the lid on it and tape it up, and that'll be fine just for testing purposes. So as you can see, guys, it's now the lid is taped on, the end is taped up, so it can't really move, and it should be safe enough. So the nice thing about that is that this now straight down and straight into the back of the inverter. Right, so now that I know which of the two is going to be the pause, it's going to be this one. And what I can do is position that about there and then make a piece of copper bar. Let's take some of this copper bar, bend it to shape so that it comes up and onto here. And then when the negative is coming in from whichever side it's coming from, it can go straight to this side of the negative contactor. So this is the positive contactor and this is the negative one. Good. At least we're making some progress. Right, guys, well, as you can see, we've done a little bit more work, and we have a bus bar, kind of. It was a bar or something similar to this, which kind of got mangled a bit to fit. So that's going from the pause down to the fuse. I'll have to figure out some way of putting a tab on there, one of these little things, just to pick up these connectors. Sorry about the lights a bit. That aluminium's a bit glary. So yeah, I need to be able to put a tab on there, but that should be easy enough done. I thought it was quite fun. I've used these little screws. They're splined, I think is the name of the tool. That's the type of tool that you use to take it off. It's a spline tool. Anyway, I thought it was quite fun. What I did was I took a couple of these and put them, 4 of these, and put them underneath. So there's a screw coming up from below. It goes into the bottom of one of these, and then these screw down into them just to hold this in position. It means that I can take these 4 screws out and take that off, and it leaves the mounting post behind. But I thought it was quite fun to use these spline screws, which are bolts or whatever you call them. They were in the original eGolf battery pack, so I thought it was quite a fun thing to do, to reuse those. But anyway, I'm hoping tomorrow to get this installed in the car. I got some more 35mm square cable that came today, which I'll use for a link wire. I'll be using a 50mm square cable going from the front to the back of the car, but for testing purposes this will do fine. So I'll use that, get this into the car, and who knows, tomorrow we might actually get spinning wheels. Yeah, that would be good fun, because I've driven this car using the motor, but only using a 1500 watt e-bike controller, so wasn't exactly fast, but it was enough to move it around the driveway and get it in and out of the garage. So it'll be fun to see what it's like with the full 80 kilowatts. Yeah, looking forward to that. Anyway, I shall wrap up here and see you again in the morning. Bye for now.